All right, let's talk data. If you work with data at any serious scale, you know that feeling, right? The pain of waiting for these massive jobs to finish, and then the shock of the cloud bill that follows. Today, we're going to dive into a much smarter way to handle your data on the Databricks platform. It's called incremental processing, and trust me, it's a total game changer.
And this right here, this is the core question we need to ask ourselves. In the world of big data, things are always changing, always getting updated. But does it really make any sense to rerun your entire massive pipeline every single time a tiny little kilobyte of new data shows up? The answer, of course, is a huge no.
Just look at the difference here. It's night and day. On the left, you've got the old way, full reprocessing. It is slow, it is incredibly expensive, and you're literally paying for your computers to reprocess data that hasn't changed one bit. And then on the right, you've got the new way, incremental processing. It's lean, it's fast, and it is hyper-efficient because it only cares about what's new.
Okay, so here's our game plan for breaking this all down. We're going to start with the problem itself, what we call the reprocessing trap. Then, we'll walk through the Databricks solution piece by piece. Smart ingestion, efficient processing, super reliable storage, and even automated maintenance. And it all leads up to that final, incredible payoff. Let's do this.
First up, the reprocessing trap. And this is a super common scenario. It's when our ETL jobs are built to just wipe everything clean and start from scratch every single time they run. It's a brute force method that wastes a truly staggering amount of time, money, and compute power.
You know, what's a great way to think about this? Imagine you're a librarian. Full reprocessing, that's like your boss telling you to reread every single book in the library, cover to cover, just because one new paperback arrived. It's completely absurd, right? The incremental way is the sane approach. You just read the new book and add it to the index. Simple.
So how do we actually escape this trap? Well, it all starts at the very beginning, with smart ingestion. The key idea here is to only bring in the data that is new or has actually changed. And Databricks gives you a really powerful set of tools to do exactly that.
And you can see here there's no single one-size-fits-all answer. It's a whole toolkit. Whether you're grabbing files from cloud storage with Autoloader, pulling from enterprise apps like Salesforce with Lakeflow Connect, or tapping into real-time streams, Databricks has a specific tool that's built for that exact job.
Now, for a huge number of people, Autoloader is the absolute star of the show. See, instead of slowly and expensively scanning an entire directory to see if there are new files, Autoloader uses a much smarter notification system. It basically gets a little ping every time a new file lands, which makes your data ingestion super fast, scalable, and way more affordable.
Okay, so we've smartly ingested only the new data. Awesome. The next logical question is, how do we process it without wasting a ton of money? How do we avoid that classic trap of paying for giant compute clusters that are just sitting around, doing nothing, waiting for data to show up?
And this quote just nails the classic dilemma. For years, the word streaming basically meant expensive. It meant having these always-on clusters that were just burning through your budget 24/7, even when there was zero data to process. And that's been a huge roadblock for a lot of companies.
And here is the beautiful, elegant solution. For any job that doesn't need to happen in less than a second, you use this special trigger called trigger.availableNow. What it does is it spins up the compute, processes all the new data that's piled up, and then, and this is the magic part, it shuts the compute right back down. So you get all the power of a streaming pipeline, but with the costs of a simple batch job. It's the best of both worlds.
Now, to manage all this, Databricks gives you Lakeflow, which you might have known as Delta Live Tables. This is so cool. Instead of you having to write tons of code to manage the pipeline, you just declare what you want the final data to look like. You focus on the what, and the platform automatically figures out the most efficient how, handling all the scheduling, scaling, and messy dependencies for you.
So, we've ingested the new data, and we've processed it efficiently. But where does it all live? Well, this whole system is built on an incredibly powerful storage foundation called Delta Lake, and it was designed from the ground up to handle these kinds of incremental changes with total reliability.
And these are really the pillars that make Delta Lake so trustworthy. You've got things like ACID transactions, which basically means your data will never get corrupted. You've got time travel, so you can easily go back and look at or restore older versions of your data. It's just a rock-solid foundation for everything we're doing.
Now, a command that is absolutely essential for all this is merge. This is how you handle changes to data that's already in your tables. Things like corrections or late arriving updates. It lets you do what's called an upsert. So if a new piece of data matches a record that's already there, it gets updated. If it's brand new, it gets inserted. It's the engine that powers all your updates.
Okay, as your data grows, keeping it organized so your queries are fast is critical. The old way of doing this was called partitioning, but honestly, it could be really rigid and often inefficient. The modern solution in Databricks is liquid clustering. It's a much smarter, much more flexible way to lay out your data to keep queries snappy, and it can even adapt as your analysis changes over time.
Let's dig into why that really matters. With old-school partitioning, if you pick the wrong column to partition on, you could get really unbalanced, lopsided data. You'd have some partitions that were huge and slow to query, and others that were tiny and basically empty. This problem, data skew, is a notorious performance killer.
And here is the solution in action. Liquid clustering just avoids that problem. It dynamically and intelligently organizes the data in a much more balanced way, which makes your queries so much faster. And the best part? You can actually change how the data is clustered later on without having to rewrite your entire table. Your data layout can literally evolve with your business.
So liquid clustering keeps our data layout nice and efficient. But there's another kind of maintenance we have to think about. See, over time, all of these little incremental writes can create a bunch of small files, which can start to slow things down. But of course, Databricks has an automated AI-powered solution for that too.
Here's how this works, and it's pretty brilliant. First, the platform's AI just watches and analyzes how your tables are being used. Then, based on that, it intelligently figures out which tables could use a little tune-up. And finally, it just automatically runs commands like optimize to combine small files and vacuum to clean up old stuff. You don't have to lift a finger. It's like having a tiny robot DBA working for you 24/7.
Okay, so after we've put all of these smart techniques into place, from ingestion to storage to automated maintenance, what's the bottom line? What's the actual payoff? What do you really get from adopting this incremental approach?
Well, the payoff really comes in three huge areas. First, massive cost reduction, because you're only paying for compute when it's actually working. Second, a drastic increase in efficiency. Your pipelines just run way faster because they're doing less work. And finally, you get much fresher data, which lets you make decisions in near real time.
And let's be really clear here. We're not talking about small, marginal improvements. Adopting a true incremental strategy can lead to a potential reduction in your cloud processing costs of up to 90%. Just let that number sink in. That is absolutely transformative.
And really, that brings us to our final thought. When you free up that much time, that much money, and that much compute power, it just unlocks incredible new possibilities. You're no longer just trying to keep the lights on. You can start thinking about real innovation. So the question is, what will you build with all the resources you save?